Hello. Our study is on the hypersonic effect and its impact on cognition. Um, our experiment aims to test whether ultrasonic frequencies, those above 20,000 hertz, have an impact on human cognition. And given our research, we believe that humans would experience a notable change in their psychological state, as it represents increased activity in the brainstem and thalamus. Thus, in theory, it should affect how information is relayed and impact consciousness/focus levels and improve cognition. However, research on the cognitive impacts of the hypersonic effect are quite scant, and we aim to test cognition in terms of the four most common forms of short-term memory encoding: acoustic, tactile, visual, and semantic. And the implications of this, if our hypothesis is proved true, that we could improve our cognitive abilities just through listening to these high-frequency sounds, which is quite exciting. The hypersonic effect, as seen in this graph, is any frequencies above 20,000 kilohertz is considered ultrasonic or hypersonic, as we can't actually hear it, and so in theory it should have no impact on the brain. However, in this 2000 study done by Uhashi et al. In Japan, they compared the enjoyment levels of participants when listening to music without ultrasonic frequencies and with ultrasonic frequencies, and they performed EEGs on it and a PET scan, and they found that with ultrasonic frequencies included in the sound, the participants reported more enjoyment as well as increased activity in the brainstem and the thalamus, which the thalamus is related to sensory processing apart from smell, and the brainstem kind of controls a lot of core functions. This is more of the data on it, as you can see by the density of colors in graph A over here, and the PET scans here. We can see the exact areas of the brain which is impacting. And these two graphs represent the differences in brain activity with these sounds being played. There is contrary evidence. Martin et al. Tried to replicate the study, but found that there was no significant impact when hypersonic frequency was being played purely on enjoyment levels. However, this study did not use any EEGs and was not studying the brain itself, only kind of testing user response or participant responses to music. And they, the conclusion was that it was in reference to music with hypersonic frequencies included that people enjoyed it more, so it was possibly researcher bias or a self-fulfilling prophecy, so errors in the research methods. However, Fukushima et al. Another study done in Japan reinforced the studies and expanded that into showing how different hypersonic frequencies impacted the brain, but also with alpha 2 EEG scores found that it did impact the brainstem and the thalamus again, or at least the lower portion of the brain, with a significant, a statistically significant effect. And there's a lot of evidence in other research through Letvin et al., Kruger et al., and Palmer et al., that music and frequencies can impact our cognition and our cognitive states. So we believe that there is precedent for the hypersonic effect. And now on to methods. Come.
We're ready.
Come.
Can we edit it?
Yes.
Oh, okay, thank God. Okay, wait, can I put?
Mm-mm.
I can't use.
Yes.
Okay. How do I control it?
Okay.
Oh, yeah, okay. Did you introduce yourself?
No.
You should have. Alright. My name is Kaya. I will be presenting the methods. So this experiment will be single blind, as the researchers will decide whether or not to play the sound for each corresponding group. The sampling method will be convenience sampling, and the participants will be randomly allocated into two groups. The test or experimental group will have the HSC sound played as they take the test, while the control group will have no sound while they're taking the questionnaire. The independent variable is the time at which the HFC, or the 20 kilohertz audio, is or is not being played, and the dependent variable is the questionnaire score. For our test procedure, so the first one we're going to be testing is acoustic encoding. This is essentially the process by which all auditory aspects and information from an experience are understood within the brain. This includes sounds, words, and other auditory input. How will this be tested? So through the human benchmark, words are generated and displayed on the screen, and one of our group members is expected to read each word as it shows. If the word is new, the participant says it is new. As the test continues, both new and old words will regenerate, challenging the participant's acoustic memory. Should a word repeat itself, for example here with the word bistro, the participant will say seen. The participant has 3 chances to respond correctly, and we will record their final scores once they make 3 mistakes. The second encoding is semantic coding, which is essentially the ability to put meaning or context to a given phrase, idea, or event. This usually encompasses concepts, just spoken ideas, and remembering definitions and dates. How will this be tested? A series of phrases from this questionnaire are read aloud. Comprehensive questions then follow. The questionnaire extends beyond these 3 questions, technically to 10 questions total, and we will record every question answered correctly by the end of this round.
And a little bit of add-on to that, we designed this one so that it fits within the 7 plus or minus 2 rule, so we're testing the semantic encoding at each stage.
The third one is visual encoding, which is the process by which visual sensory information is interpreted. So mental pictures are one way in which people utilize visual encoding. The amygdala has an important role in this type of short-term memory. The human benchmark will completely test this via the visual memory test. Essentially, a sequence of squares will show up, and the participant is expected to match the sequence. The further the participant progresses, the more complicated the sequence will become. So the furthest level they reach will then be recorded. Lastly, the fourth, which is tactile encoding. This is a system in which our brains process information based on sensory feeling, and essentially it includes remembering the feeling of like a first kiss, or a hot fireplace, or the taste of chocolate, essentially anything that has to do with physical touch. This will be tested via objects, so we would blindfold the participants and give them 5 different objects at a time. Eventually, as the sequence goes on, we would repeat giving them an object, and their main objective is to figure out whether or not they've felt this object before. After three incorrect answers, we would then record their accurate score.
So we have not actually performed any tests yet, as we're quite early on to this. However, the statistical method that we will be using once we have the results is to use a tri-squared test for independence. So essentially examining the averages between the 2 groups to see if there is a statistically significant difference with a p-value of 0.5. As we're using the human benchmark, there is a lot of statistics out there on the bell curve of these abilities. So if we don't have enough control group research, we can use the human benchmark scores in addition to the information that we have collected.